Hi everyone, this is your math guru. In this video, I'm going to prove or show you how to prove the following trigonometric identities using the examples given. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In the first example, I have tan alpha plus cos alpha in a bracket multiplying sin alpha equals to sec alpha. In order to a left-hand side and a right-hand side, you're going to prove the more complex side, and in this case that's the left-hand side, so I'm going to prove that it's equal to my right-hand side. The following trig identities are going to be used. I have tan theta equals sine theta over cos theta. If I have cot theta, that's 1 over tan theta, and that's the same as 1 over sine theta over cos theta, and that will give you cos theta over sine theta. Also, sec theta is equal to 1 over cos theta. So back to proving our left-hand side. For our left-hand side, we have tan alpha plus cot alpha multiplying sine alpha. Changing our tan alpha, we have sine alpha over cos alpha plus our cot alpha becomes cos alpha over sine alpha multiplying sine alpha. What we're going to do is expand the bracket or simplify by multiplying all the contents of the bracket with a sine alpha. So what we're going to have is we have sine squared alpha over cos alpha plus cos alpha over 1. Our LCD, or our lowest common denominator, is cos alpha. Therefore, making the denominators the same, I'm going to multiply my right-hand fraction with cos alpha at the top and at the bottom. So my expansion becomes sine squared alpha over cos alpha plus cos squared alpha over cos alpha. Now the denominators are the same. Placing them under the same denominator, I have cos alpha. At the top, I have sine squared alpha plus cos squared alpha. Using the trig identity that states that sine squared theta plus cos squared theta equals to 1, my sine squared alpha plus cos squared alpha will become 1 over, still have the same denominator, cos alpha, and using the trig identity that states that sec theta equals to 1 over cos theta, my 1 over cos alpha becomes sec alpha, and that is equal to my right-hand side as shown. Let's look at another example. In the second example, I have 1 plus cos A over sine A plus sine A over 1 plus cos A equals to cosec A. Like I did earlier, you have to determine which side you're proving. I have my left-hand side and my right-hand side. In this case, I'm going to be proving from my left-hand side. And what I have is 1 plus cos A over sine A plus sine A over 1 plus cos A. To merge the fraction, I need to find my LCD, or my lowest common denominator, and in this case, that's sine A in bracket 1 plus cos A. Finding your LCD means your LCD has all the factors of your denominator as shown. So therefore, to put them under the same denominator, on the left-hand side, I'm going to multiply with 1 plus cos A. And whatever you do at the top, you do at the bottom. 1 plus cos A. Multiplying, I have 1 plus cos A over sine A. And on my right hand side, I'm going to multiply with sine A. So I have sine A over 1 plus cos A multiplying sine A over sine A. Observe that now the denominators are the same, so therefore I'm going to put both under the same denominator, which is also my LCD. That's sine A multiplying 1 plus cos A. At the top I have 1 plus cos A multiplying 1 plus cos A plus sine A squared, or sine A multiplying sine A. If I simplify, I still have the same denominator, which is sine A multiplying 1 plus cos A. At the top I have 1 plus 2 cos A plus cos squared A plus sine squared A. What I've done is I've been able to foil my 1 plus cos A and 1 plus cos A to give me 1 plus 2 cos A plus cos squared A, and sine A times sine A will give me sine squared A. So using the trig identity that states that cos squared theta plus sine squared theta equals to 1, I'm going to group my like terms. So I have cos squared A plus sine squared A giving me 1. I have 1 plus 2 cos A plus 1 over sine A multiplying 1 plus cos A, and that will be 2 plus 2 cos A over sine A multiplying 1 plus cos A. If I factorize at the top, 2 is a common factor, so I have 2 open bracket 1 plus cos A over, I still have my sine A, 1 plus cos A. What has happened is I can simplify. I have 1 plus cos A at the top, dividing 1 plus cos A, that cancels out. So I have 2 over sine A, and we know that sine A or cosec theta is the same as 1 over sine theta. So going back, 2 over sine A becomes 2 cosec A, and that is also equal to my right hand side. Thanks for watching. Bye.